Here we are going to look at velocity time graphs. These are graphs which look at the change of velocity over time. It may be useful for you to look at our video on distance time graphs before starting this video. Take a look at this simple velocity time graph. The points A to B show an increase in velocity of 18 meters per second. The gradient or steepness of this line is the same as this change in velocity divided by the time taken to change. Velocity divided by time is the rate of change of velocity of the object, which is called acceleration. We can find the acceleration of an object at any point on a velocity time graph by finding the gradient at that point. A straight line will show a constant acceleration. A change in velocity of 18 meters per second divided by a change in time of 10 seconds gives us an acceleration of 1.8 meters per second per second. What do you think the acceleration between points B and C and D is? Pause now and have a go. The acceleration between B and C is fairly easy. As there is no change in velocity, the object is moving with a constant speed. Therefore, it has no acceleration. A horizontal line on a velocity time graph shows a constant speed. Be careful though, a horizontal line here can still mean movement, whereas on a distance time graph, it meant no movement at all. The acceleration between C and D is found using the gradient. The change in velocity is again 18 meters per second. But because it's a decrease, we must use negative 18 meters per second. This occurs over 20 seconds. So negative 18 divided by 20 equals negative 0.9 meters per second. We can either say the acceleration is negative 0.9 meters per second, or that it's decelerating at 0.9 meters per second, removing the negative. If we have a curved gradient, this shows that the acceleration is changing, not constant. As you can see, an increasing acceleration is a curved line, which has an ever-increasing gradient. A decreasing acceleration has a gradient that gets less over time. To find the exact acceleration from a curved graph, you need to find the gradient at that point in time using a tangent. This is a line drawn at 90 degrees to the curve at that point. Use this to form a right-angled triangle and find the change in velocity and time. In contrast to distance time graphs, velocity time graphs have an extra special feature. Because the velocity of an object is found by dividing distance by time, we can rearrange and find distance by multiplying velocity and time. On our graph, these values multiplied are equal to the area under the graph. Let's take our original question. The distance this object travelled is the same as the highlighted area under the line of the graph. We can find the exact value for the area by noticing this is a trapezium and using the relevant equation. We can also find it by splitting it into multiple shapes, finding the area of each, then adding them back up. It's useful to know how to do it this way in case your area does not form an easy shape. We can split this area into two triangles and a rectangle. Here we have the area under the graph split into three parts. Now try to calculate the value for each part. Remember, the equation for the area of a rectangle is base times height. whilst the area of a triangle is found by half base times height. Pause the video and have a go. Let's see how you did. Part A, a triangle, is calculated by multiplying half by 10 by 18, which equals 90. Part B, by multiplying base 20 by height 18, so 360. And part C is calculated using the same equation as 1/2 times base 20 by height 18, which equals 180. In total, 90 plus 360 plus 180 means the object travelled 630 meters. So there you have a quick guide to finding acceleration and distance travelled using a velocity time graph.
If you liked the video, give it a thumbs up.